Good evening, everyone. Welcome to StackLeague AWS Tech Sessions, Serverless, and Containers. I am John Louis Bersamina, and I'll be your host for tonight. We have an amazing resource speaker for tonight's session, and we hope you'll learn a lot. But before that, to give us an overview of StackLeague, especially if it's your first time to join a StackLeague event, everyone, please help me welcome Ms. Cassie Kalunod, Growth Associate of StackLeague.
Good evening, everyone. I will be giving po a short introduction for StackLeague. So, first, ano po yung StackLeague? StackLeague is the Philippines' first year-round competitive programming league with a mission to develop programming leaders that inspire a nation into coding. So, since it's a competition, there will also be prizes. So, ano po yung mga prizes natin? Launched last March 16, this pioneering programmer league is gathering over 4,000 tech talents across the country to test their coding acuity with a promise of nationwide recognition, thousands of prizes, hundreds of tech job opportunities, and invitation-only events. So, mga exclusive events po for our winners. And also from 200,000 pesos, the cash prize pool is now at 300,000 pesos. This will also continue to increase. Next po, Stack League wouldn't also be possible without our partners. We have our co-presenter Job Street. We also have our gold sponsors, Workbank and Rakuten Viber. Our silver sponsors, Amazon Web Services and Caliber. Our bronze sponsor, Accenture, and media partners Inquirer.net and SparkUp. We'd also like to thank our community partners who help the league reach as many programmers in the country as possible. So here are our community partners. Now, for those who are new at Stack League, this is how the ranking system works. So you start at the bottom with the 0 points, then you solve as many challenges as you can and earn the corresponding points. So the more points you get, the higher your ranking goes. And with the higher rank, the more opportunities are unlocked for you to access. Next po, these are the supported programming languages of the league. We have JavaScript, Java, Python, C Sharp, and PHP. Next, we also have other highlights here at Stack League. Meron tayong weekly ranking and treasure chest. For this one, the mechanics are similar. You earn as many points as you can during the week and be part of the top 10. The weekly top 10 will then each get to earn 500 pesos cash. Next po, we also launched the team category last July 11. In this category, you can now compete with a team of 3 to 5 members for points and prizes. And the total points of the team will be the sum of all individual points earned by each member. So that's it for the highlights and mechanics of Stack League. If you're up for the challenge, then see you in the league. Yun lang po. Thank you.
Thank you, Miss Casey. And before we proceed, here's some reminders. Don't forget to type your question in the comment section and we'll address them later at the Q&A session. And without further ado, let me introduce to you our guest speaker. She is a solutions architect from AWS Philippines. She helps customers in their cloud journey and provides them guidance and consultations. She currently holds 7 AWS certifications and a certified Kubernetes application developer. With over a decade of experience under her belt, she is adept in release management, continuous integration, and delivery, and in building microservices applications. Everyone, please help me welcome Ms. Damselle Navarro.
Hi, good evening. Welcome to all of you. I hope you're all having a great day. So I see a lot of people, or I see a lot of students, no, coming from different parts of the Philippines, and it's good to have you all here. So we have a lot from Davao, from Cebu, from Mandaue. So hi to all of you. So I hope you will learn something new for this evening. So again, my name's Damselle Navarro. So you can just call me Dams. So I'm a solutions architect at AWS Philippines. So let's get straight to our session for this evening. So for tonight's agenda, so this is what we will be covering. So we will be tackling on what do we mean by serverless. We'll have a short definition of those, and also for containers. We'll also discuss some common use cases where you can use serverless and also containers. So we'll also be covering what is containers and Dockers, plus the Elastic Container Service, AWS Fargate, as well as different services that is serverless in the AWS landscape. Okay. So to start, actually let's discuss the evolution of compute, and it has actually come a long way. And there's already a paradigm shift that's currently happening. So before, there was a time that everything that we use is physical machines, right? So you had to buy server blades, you had to put them in stacks and then keep them all in a data center, and you will have to manage all of those. And then the virtual machines came. So where one or more virtual guest machines run on a physical host machine or the servers themselves. And then containerization was introduced. So this is where you get to build lightweight, standalone executable package of software. And of course, right now there's what we call the serverless. Okay, and with this evolution of compute, there are just a lot of options to further simplify how you host or build your applications. And for this session, we will be focusing on containers and serverless. So what drives this shift? What drives this evolution? Or what's the reason behind why we try to innovate, right? Our compute or the services where we host our applications. And a lot of this is because companies or people want to get to market faster. So they want to release products to customers or to consumers or to their clients as fast as possible. And when they have this idea, you want to make sure that those ideas be translated to a products or to applications in the shortest time possible, right? So maybe the reason for this is because you want to push, this product so that it can solve a lot of problems that consumers are experiencing or they are facing, and it might be because it is relevant for you to release that product or application right now, or maybe because if you deliver late, then this might give your competition, the advantage when it comes to innovation. So another reason why people want to adapt, containers and serverless or modern application in general is because they want to lower the cost of ownership. So they want to replace the capex with opex. So for students here who have not yet, they're not yet familiar with this terminology. So capex is the upfront cost incurred for, assets that is being bought by different companies that will be used in the future, while opex is the day-to-day operational expenses that the companies, incur. Okay, and aside from that, when you use this, containers and serverless, or when you host something in the cloud, you can be rest assured that there are, continuous price reductions that can happen based on historical figures also, and there are also various pricing models that you can choose from, right? And here in AWS, as you grow your usage, right, there are a lot of volume discounts that you can get. So another reason maybe because is they want their applications and infrastructure to be reliable, to be highly perform highly, and also to be scalable, right? And of course, everyone wants their application to be secure and to have some sort of isolation by design. So those are just some of the reasons why serverless and container adoption is growing fast. And because it enables also customers to be able to focus on things that could benefit their customers, their clients, and not focus too much on the infrastructure management. Okay, now let's get to the meat of things. So this is actually a bit of a primer before we get an overview of the different services that you can use in AWS for containers and serverless. So I just want everyone to be on the same page, and I want everyone to know what container is or what Docker is before we dive to that. Okay. So first things first. So what is a container? So a container is an isolation process, and it is also a standard way, to package your applications. So they are very lightweight and they are portable and they are an easy way for you to distribute your applications. Okay. So some companies use this as a standard unit of deployment for softwares that they create, because containers can run reliably across a different compute environments. So what do we package in a container? So we said that a container is an isolation process, and it's a way for you to encapsulate your application and whatnot. Pero what goes on inside? What's inside that container? What does it contain? So it contains the components that make up an application. So you have your runtime engine. So it may be JVM, .NET, or Node.js. Then, of course, you have your application code, the meat of your containers. And also, you can include their dependencies like software, package libraries that your code needs to run to. You also have their configuration items like environment variables or connection strings, and so forth. So containers provide you a way to package all of this into a single object. Okay, and you might ask, or you might be wondering, why do we need to have a standard way to package your code or to package your application? What problem does Docker what problem is Docker trying to solve, or what benefit can this give you? Okay, so I don't know if you've encountered this this question before, but during my time as a DevOps engineer before, I always hear this question a lot. So it worked on my machine, but why not in production, right? So it's like an unsolved mystery waiting to be solved. And believe me, this is one of the hardest questions that you will get from your developers if you're a DevOps engineer or if you're a systems administrator. Okay, so when you are in a company, there are a lot of different environments that you interface with. There's your local laptop, your staging, your production, or even your on-premise environment. But there's no guarantee that the same thing will exist in your staging or production environment versus the ones in your local laptop, of course, because you are responsible for your local laptop. You have complete control on what you want to install on it, what dependencies you need to do. You just simply install it and whatnot. But on staging and production, of course, that's going to be a different scenario. Someone's going to be in charge of that. They need to know what your code need in order to run properly. And sometimes there's what we call the dependency drift, wherein one version of a dependency is different from your local laptop versus the staging or the production environment. And this causes a lot of problem, when deployments happen, when you need to push your applications to production and whatnot. So the containers helps us address that sort of problem. Okay, so Docker provides you an abstraction layer, allowing you to run your containers applications on many platforms. So all of your application components, they get packaged into a single container image, and then that's what you use to deploy to the different environments in your company. While we've been talking about Docker a lot, and sometimes Docker is already synonymous to containers, but Docker is just one of the number of container runtime ecosystems that you can use, right, out there. There are what you call the Rocket or the RKP and the Containerid. So, but Docker has been the most prevalent one in the industry. So, yun yung pinaka-common na ginagamit ng mga developers and even by a lot of companies also. So what's the difference between virtual machines and Docker? So virtual machines and containers differ in several ways. So the primary difference between them is that the container provides a way to virtualize the OS so that multiple workloads can run on a single OS instance. Okay. Unlike in a virtual machine, the hardware is being virtualized to run multiple OS instances, as you can see here in the picture. So you can see that the virtual machine has its own guest OS, but for the container, this is not the case. Now, if we look closely into a container, you'll see that each container is a runnable instance of an image. And a Docker image consists of different or several layers. And each of this layer actually corresponds to certain instructions or commands inside of your Docker file. And this Docker file is actually a file that's like a blueprint for your container. So it is a text document and it contains, commands that a user would call in the command line to assemble the image or to package the image. So when you build that Docker file, you get a Docker image. Okay. So one tip that I could give you is that when making your own Docker file, so you can make your images more performant, and also you can save some space if you minimize the number of layers that you use in your image. So you can do this by limiting or combining certain commands in a single line rather than breaking them apart in multiple lines. So the commands that is that creates these layers is the run, the copy, and the add command. Okay. So now, because your runtimes, your code, your dependencies, and your configurations are all encapsulated within a container, so what happens is when your application will run more reliably across multiple different environments, because you're sure that you're deploying the same thing on all of the environments, and all of their dependencies, it has the same version. That the configurations are the same, or it may change because if you're using environment variables, for example, but other than that, everything should be the same. Okay, and by doing that, it reduces the time that it takes to move from one environment, for example, from your laptop to your staging and then to your production environment. So let's quickly recap the benefits that you get when you use containers. So first, of course, your applications will run more reliably across local or non-prod or production environments, because again, they're packaged and they're encapsulated in a single image. Now, we've mentioned that containers provide an isolation process, or a way for your applications to be isolated. And this isolation of dependencies and runtimes mean that you can run different apps or different versions of the same application simultaneously on the same operating systems. So this also opens a way for you or for some companies to do polyglot programming. So if you have not yet heard of polyglot programming, so that's when you develop a software or an application using different programming languages. So they do this to capture some additional functionality and efficiency that might not be available in the programming language that they're using, and they wanted to explore another programming languages and just spin it up and just integrate it with their current containers. Okay. And of course, this also leads to better utilization of your resources, because before, diba, we see that one application gets deployed to one server, or one application gets deployed to one VM, but only a limited number of VMs can run in a whole server. But if you use containers, or if you use Docker containers, right, you can run a lot, like 10 or 50 containers in a single instance of an EC2 instance or a virtual machine. So it gives you like better resource utilization, and make sure that you are utilizing your resources properly. You're getting the most out of your buck. So of course, aside from that, the major benefit that you also get is the speed. So since this provides a way for you to isolate and to encapsulate your images, your code in an image, so developers get to build and run the containers locally. And when it is ready to push to your different environments, right? So what they can do is they can just push that image to an image repository, and then if they have CI/CD servers or continuous integration servers, then those servers can just pull the image and then run that image, and then the container gets created, and maybe do some integration tests against it, and make sure that it passes certain unit tests if they have so. So again, by doing this, the same container or the same image gets shipped to a staging environment where its runtime behavior can be checked using load testing or manual testing, and then finally shipped to production. So the good practices here is that when the devs have pushed something for example, if they have pushed the image to the image repository, there should be no changes happening to that, and that image will be deployed to both staging and production. And maybe if there are some changes that might happen, it might be on the environment variable or some configurations or connection strings perhaps. But other than that, there should be no changes inside of your Docker images. So where can you use containers? So what are the common containers use cases that we see our customers use? So we see them using this for batch processing, for data processing. So you can use this for ETL jobs to start them quickly and to scale them dynamically in response to certain demands. You can also use this for backend services, for web, for static, or even for hybrid applications. And also you can use this for AI and machine learning, where you can use containers for your machine learning model trainings, and also for inference, and to make sure that they run close to where your data sources are. So if you use CI/CD pipelines or your servers, you can also use this with Jenkins. So you can use it as a worker node to your master Jenkins server, or you can even use it as a client-side load testing, for our QAs out there. And also, if you want to migrate from using legacy applications to using modern applications. Okay. So let's say you've decided to start using containers, and now you've got tens or 20s or 50s or even hundreds of containers, right? And sometimes one application can have multiple instances of containers to handle the load. So how do you now manage all of that? And that's where Amazon Elastic Container Service can actually help you. So Amazon ECS, or Elastic Container Service, is a fully managed container orchestrator platform that supports Docker containers. So it helps you deploy, to manage, to scale your container workload on AWS without having you to install any software. So some of the features that you get with ECS out of the box is that Of course, number one, it's fully managed. So that means you don't have to manage the control plane, and that the service scales as your architecture grows. Okay. The second benefit that you get is that you get to enjoy the AWS VPC networking mode, where it allows you to set one IP address per one ECS task. And sometimes that's a requirement for some of our applications or some of our developers. And we'll get to the definition later on of the ECS task. So it's okay if you don't understand that part. So we will dive into the different components of ECS. So you also have the option for advanced task placement, or the ability to choose which Elastic Compute Cloud or EC2 is going to be placed on. So aside from that, ECS also has a deep integration with AWS platform by design. So this allows you to get all the benefit of IAM security, VPC networking, load balancing, and also for monitoring like CloudWatch metrics, where you can configure the containers in your task to send log information to your CloudWatch logs. Okay. It also has its own command line interface, which is the ECS CLI. So you can use this for creating, for updating, or for monitoring your clusters or even your containers. But of course, if you are using like infrastructure as code tools like CloudFormation, CDK, Terraform, and whatnot, you can still use that. So you don't have to worry about using this ECS CLI. Okay. So aside from that, you get a powerful scheduling engine, which also allows you to configure the auto scaling of your containers or your tasks. And of course, you get the benefit from the AWS global footprint that AWS has. Okay, so with that said, let's look at the available services that we have in AWS and that you can use for getting, for setting up your own or for running your own container services. Okay, so at the orchestration layer or the management layer, we have two services here that you can choose from. So we have the Amazon ECS or the Amazon Elastic Container Service. We also have the Amazon Elastic Container Service for Kubernetes, or what we call the Amazon EKS. Okay, so if you want a container service that's most deeply integrated with the rest of the AWS platform, then you can use Amazon ECS, which we fully control, so that every time we release a feature, we launch, we make sure that those features work closely with ECS out of the box. Okay, but of course, if you prefer having a managed Kubernetes service, or if you've been using Kubernetes for the longest time before, and if you're comfortable and familiar enough with Kubernetes, then you can use Amazon EKS. And just to note, about 84% of the Kubernetes workloads right now in the cloud is running on AWS. So rest assured that you will get the most benefit, and that AWS supports those native integrations with Kubernetes. So for hosting, you can choose to run your containers on ECS, either on EC2 launch type, where you get to manage the underlying instances or on which your containers are running, or if you prefer not to worry about the servers or the clusters itself, and you want to manage the containers only at the task level, then you can choose to use AWS Fargate. So finally, we provide a registry service, which is Amazon ECR, where you can store your container images. So we've mentioned earlier that when we package your code, so this produces a container image, and of course we needed a place to store those images, right? So if you have different versions of your image or your containers, of course you need to store them somewhere, and that somewhere is the image registry. And we have the Amazon Elastic Container Registry. in AWS where you can do that. So of course, it's okay. You can also, if you have a third-party image registry that you use in your company, so that's okay. That is fine as well. You can still use that with Amazon ECS. Okay, so at a high level, so what are the ECS components that we need to know of? What are those components that you're going to interact with? So we have here the ECS cluster. So this is the ECS cluster. So this consists of a group of container instances or EC2 instances, or in the case of Fargate, it's a collection of or a group of tasks. So they reside within a single region, but they can span across multiple availability zones. So that's a way for you to provide redundancy for your tasks. So aside from that, we also have here the ECS control plane. So this one right here. So this is fully managed by us and it is abstracted to you. And what you just need to do is to, the ECS agent actually interacts with this, and you can when you run some commands in your command line. So that's how you interact with it with this control plane. So as mentioned, the EC2 instance here or the cluster here are a group of EC2 instances that makes up your whole cluster. So this is where you can run or host your task or multiple tasks inside. As you can see here, there are 2 tasks running inside an EC2 instance. So this instances has a ECS agent installed inside, as you can see here. So it has a specifically defined policies or roles and has been registered to your cluster. So for the AMI or the Amazon Machine Image, so you can use the Amazon ECS optimized AMI, which is already pre-configured with an ECS agent and the Docker daemon. But if there's a need for you to use a different AMI, then that's fine as well. So as long as it has the ECS agent and also the Docker daemon plus all the Docker runtime dependencies that you would need, so that is fine. So we also have here the ECS agent. So this ECS agent acts like a middleman that will take care of the communication between your control plane and your cluster, right? It talks to the control plane and gets some instructions from it on how to orchestrate the launching of your containers inside of those instances. So it gets all of those instructions from your control plane, and then ECS then proceed with how to orchestrate all of that inside of those containers instances. So in terms of the scheduling and orchestration, so both of these are key components of ECS. And the cluster manager and the placement engine plays a specific role on how you would accomplish this. So the cluster manager manages the health of your instances within your cluster, and they make sure that they are all healthy and they're up and running. And the placement engine, on the other hand, they enable some advanced technique for you to for how you would place your task on an EC2 instance. So for example, if you have a certain task or container that you want to land or to reside in a certain instance type, or if you desire a super efficient bin packing instance for better economics, then you can have the placement engine do that for you. Okay. So before you start or you create a container, the first thing that you would need to create is the task, okay? And for you to create a task, you need to create a task definition first. And this task definition tells ECS what your task or container or the task itself is going to look like. So it will have details like the containers that it's going to run, of course the image that it's going to use. It will also contain the container CPU, the memory constraints, or the task permissions that is being used by the IAM roles and so forth. Okay, so aside from that, of course, you will need your load balancer. So this load balancer distributes the traffic across the different tasks that are associated with that service. Okay. So of course, as you can see here, we have more than one instantiation of a task. If you have that, then the load balancer will help you point the traffic to the right container, or if one container is already fully loaded, then it will make sure that the traffic will be sent to the other container. Okay. So that concludes our container section. Now let's take a quick pick on what serverless is and what it can bring to you. Okay. So when we say serverless, a common misconception here is that there are no servers running underneath it all. So it's just that we're talking about building and running applications without thinking about servers. So serverless actually means that there are no server management. Okay, so that means you don't need uh, don't need them to scale manually because they will scale automatically. They're highly available, and you only pay for the resources that you use. So what benefit do you get from here? So of course, the main benefit is that it eliminates the heavy lifting tasks for you. So that means you don't need to provision the servers themselves. You don't need to think about patching and even the OS maintenance. Okay? You also no longer need to worry about ensuring that your application is fault tolerant because it is already highly available. So this reduces the overhead from you and lets your developers or your DevOps engineers to have more time on developing solutions rather than administering your servers. Okay? And usually when we talk about serverless in AWS, the first thing that comes into your mind is AWS Lambda. But serverless is actually a lot more than just Lambda. So as you can see here, it shows a different serverless services across different categories. So for compute, we have here AWS Lambda. We also have AWS Fargate. For data stores, we have Amazon S3, we have Amazon Aurora Serverless, we also have Amazon DynamoDB. For integration, we have services like Amazon Event Bridge, Amazon API Gateway, Amazon SQS, Amazon SNS, and AWS Step Function. We also have their apps. And while Lambda itself already offers many key advantages in your serverless workloads, it's really when all of these components are used together that we see the big difference and the much bigger benefit that you can gain. So one thing that's common across serverless applications is they follow the design idea of small pieces loosely joined. So all of these applications are modular, meaning you can mix and match them. You can choose to use Lambda only, you can choose to use S3 only, and that's okay because they're modular. It's like a Lego block. You can pick the sizes or the size of the Lego blocks that you would need to build your application. So it's composed of multiple AWS services, and it makes it really easy for you to build new applications and functionalities through loose coupling and also with other components. Okay. So usually, when we do this, it often starts with an API. So those APIs are managed by API Gateway as application front door. And more often than not, these events or messages are the communication system in the back end with all coordinated via a workflow. So in terms of architecture, so this is an example of a serverless architecture that we see being adopted in a lot of different use cases. So it's divided into 5 layers. So you have here the content delivery, the static content, the API layer, the application layer, and also the data layer. So usually when you interact with the application, so it starts with the Amazon CloudFront if you have enabled the content delivery network, and this will securely deliver your data and also your content closer to your users. We also have here Amazon S3 for storing your static content. And before you could before your customers could access your backend services or your application layer, you can also have the option to set up an authentication method for your API, so you are more secured in that area. So for that, you can use Amazon Cognito. For the API layer, you can use Amazon API Gateway. So this serves as the front door for your backend services or your application layer. So for application layer, of course, you have here AWS Lambda that would run or create your business logics and functions that would need to support your whole application. We also have here the Amazon DynamoDB that will serve as your data layer. So I'd say these are the most common building blocks that you will see and use in building your serverless application. And we will quickly dip our toes into each one of the services so that you get a good idea of what these services do and what you can, how you could utilize these services. So to start off, let's tackle the static content and a little bit of the content delivery network. So usually when your users want to interact with your website, so what they do is, of course, they make a request either from their desktop or mobile devices, and that goes right through your domain name system, or in this case, Amazon Route 53. And Amazon Route 53, if you have not yet heard of that, it's a highly available and scalable domain name system. And this is where you could buy domains, or you could transfer in your DNS records if you have an existing domain already, or it also has the ability to let you choose which routing policy you will use and to host all of your record sets. Okay. So going back, so the domain name system or Route 53, once it receives that request, it will forward that request to your Amazon CloudFront. And then Amazon CloudFront, so it is a content delivery network, and its main objective is to distribute your content with low latency and closer to your customers. So it does this by serving your requests using a network edge of locations or points of presence that we have around the world. Okay, and after that, of course, CloudFront will be getting the static contents of your website from your selected origin. And in this case, we have selected Amazon S3. So S3, or a simple storage service, is one of the oldest service that we have in AWS. So it's super scalable, and it provides a serverless storage for you and a virtually infinite storage without having or compromise or provisioning. And it also handles millions of requests per second. So like other serverless servers, it provides continuous scaling, which means you never have to pay for idle resources. Okay. So most commonly, S3 buckets are associated with storage resources that go hand in hand with other compute resources like EC2 or Lambda. But in the serverless world, they mostly handle the static requests or contents of your website. So if you have an HTML page, or you have JS, that you want to incorporate with your HTML, then you can host all of that in S3. So I will actually give you an example, right, that I created. So it's a simple website that I created that is hosted in S3. So everything that you see in there is just in a S3 bucket. Okay, and the good thing about this is that you don't have to worry about how you would need to scale your web server, because S3 is inherently scalable and highly available. So it can scale seamlessly and serve thousands of HTTP requests per second, and it has an SLA of 99.9% of availability. So for authentication, so after your users browse your static content, which can be your splash page or corporate page or just a front page of your web application, then you may want to have some kind of authentication page that would let you check who are the users coming in from your website, or you have to need some way to authenticate those users before letting them access your backend services. And with that, Amazon Cognito helps you to do that. So Cognito lets you easily, add user sign up and authentication to your mobile and web applications. So you can have the option to use a simple authentication like username and password, or you can authenticate your users through social identity providers like Facebook, Twitter, Amazon, or you can also integrate your own identity provider as long as it supports SAML. Okay, and one of the cool features of Cognito is that it has a hosted user interface. So you can use this tool as your login page. So you wouldn't need to build your login page. What you just need to do is to integrate it with your static website or to your web application. So if you don't have the time to create your own login page, so you can just use the hosted UI. But if you want to have your own fancy login page, more customized that you need, then you can also do that. So we have here an example of what the authentication flow for the social identity providers like Facebook, Google, or Amazon would look like. So of course, the application starts, the sign up and the sign in process by directing your users to your to the sign in user interface or page, either the one hosted in Cognito or your own custom user interface. And once Cognito receives that request, then the user pool will determine which identity provider is your user going to use, and then it will redirect you to the appropriate identity provider's login page. So the user inputs, of course, his or her credentials, and then once they are authenticated, then the third-party identity provider will give you a token, which will then be received by Cognito. And then Cognito will use this to complete the authentication process and will redirect you back to the landing page that you have specified. So again, I will take you through this portion in the demo later on. So the token that it has received can also be passed to AWS services like API Gateway, which you can configure a Cognito authorizer for your API Gateway to authenticate all those users before accessing your API resources. Okay, so now that you have your static website, you have your own login page, or you have authenticated your users, now let's get to the API layer. So API Gateway, as the name implies, so it acts as a gateway or a front door for all of your services. So it is a fully managed API platform, and it creates a unified API for all of your microservices. And because this is a gateway for all of your services, of course, security is a top priority here. And some of the security features that you can get with API Gateway is the flexibility of its security controls. So you can authorize access to your APIs with IAM or AWS Identity and Access Management, or you can also use Amazon Cognito as what I have mentioned in the previous slide. So you can also incorporate AWS WAF or a web application firewall in your API Gateway that will provide you some level of protection against layer 7 attacks. Okay? So API Gateway also provides you functionalities like throttling, metering, and the ability to monetize your APIs if you need to by publishing them on your AWS Marketplace. Okay. So currently, we have 2 protocols as of the moment that API Gateway supports. So these are the REST or the RESTful API and also the WebSocket API. So the difference between these two is that HTTP is literally a round-trip conversation, or the HTTP API. So this is where the client may say, hey, API Gateway, I'm asking you something, And then the API gateway may say, hi client, I need to tell you something, and then it's done. So it's a request and response relationship. So it's like a question and answer, and then that's it. But with the WebSocket communication, it's like a client saying, hey, API gateway, I'm going to be connected to you, and then you're going to be connected to me, and then we're going to be chatty. We're going to continuously talk until the sun is down or until when one of us terminates our connection. Okay. And the interesting thing here is once they are connected and that conversation is going, the backend can actually communicate with the front end without a request being made by the front end. So this is a good choice for applications like chat clients, right? Because when you are in a chat client, you typically say your message, wait for the other person to reply back to you, but it never, like, it doesn't, the connection does not drop until you, of course, end the conversation or you close the client itself. Okay. Okay. So that's for our API layer. And for our application layer, we have here, of course, the AWS Lambda. So Lambda is a compute service that lets you run code without provisioning any server. Okay, so you just need to upload your code, and then Lambda will take care of everything required to run or even to scale your code with high availability. And then after uploading your code, then you can set up your code to automatically be triggered from other AWS services or call it directly from any web or mobile app. And there are different ways on how you can invoke a Lambda function. So it can be invoked via the AWS console, or it can be via the Lambda API, the AWS SDK, the AWS CLI, and some other AWS toolkits. Okay. So aside from that, of course, Lambda is event-driven. So that means that it can be triggered or invoked by using a trigger. So a trigger is just a resource or another service or another Lambda function that you can configure to invoke your function in response to certain lifecycle events or external requests or on a scheduled basis, like for example in a CloudWatch event. Okay. So you can also use event source mappings to process different items from a stream or a queue, and events coming from an AWS service or from an invocation such as events from DynamoDB or Kinesis or SQS. So in terms of the supported languages, so out of the box, Lambda supports Node.js, Python, Java, C#, Go, PowerShell, and Ruby. Okay, but you can also build your own custom runtime that would allow you to run a different programming language, like PHP, for example. So you can still run PHP on Lambda, but you would need to build your own custom runtime. Okay, so virtually it can be any kind of language. Okay, so aside from that, you can also connect your Lambda to other AWS services or public endpoints or database and do some transformations or data processing inside before you pass it on to a specific service. So the use case for this is, of course, you can use Lambda to be integrated with the majority of the AWS services. So this can range from Alexa to X-Ray. But something to keep in mind here is that Lambda has an execution limit of 15 minutes. And beyond that, your Lambda function will time out. So you have to make sure that your Lambda is running in a short and sweet state. Okay. So when using Lambda, so what benefits you can get? Again, you can bring your own code. As I've mentioned, you can bring your own libraries. It has a flexible use. You can do synchronous or asynchronous calls. It's integrated with other AWS services. It has a simple resource model, so you can allocate any amount of memory to your function between 128 MB to 3,000 megabytes in 64 increments. So you also have the CPU and network allocated based on the memory that you select. So it also has a flexible authorization. So you can grant fine-grained control to your functions, and restrict it to only access specific AWS services, depending on what you put in your policies. Okay, so what else do you need to know about Lambda? So in authoring your function, you can use any IDEs, you can use Cloud9, or you can use the console itself. For programming model, you can it uses processes, it uses threads, and it also has a temp folder that is used for caching. But take note that this one is ephemeral, meaning it will eventually be deleted. Okay. So for monitoring, there's also an integration with X-Ray. So you can use X-Ray with this with just a single checkbox without having to set anything up. Okay. So of course, it also has a built-in log functionality with Amazon CloudWatch logs, and there's also a storage persistence that you can do using external storage. Okay, so we have AWS Fargate. So again, this is an extension, I would say, of our containers talk earlier, because AWS Fargate is also in the you've seen this in the container landscape that we have discussed earlier on in the hosting part of the containers. Okay, so as people or customers were adopting ECS, a lot of them are still managing different things like patching or upgrading OS for the instances where that hosts their containers. And because AWS is customer obsessed and we like to innovate, and also we wanted to help our customers reduce some of this operational overhead. So this is the reason that AWS Fargate was launched. So which is a serverless way to run your containers on ECS. So in EC2 launch type, you are responsible for managing the container instances, for running the services, and also for running the tasks. While if you use the Fargate launch type, then you are going to take care of only the services and also the tasks itself. So you don't have to worry about how you would scale your instances or how you would patch your container instances. And by using Fargate, that means you can just focus more on your application and how your application would behave and run and whatnot. So even though Fargate is serverless, then there are still some similarities between Fargate and the EC2 launch type. So both of them uses the same task definition schema, and the API that they use to communicate with the ECS is both the same. And if you want to migrate from EC2 launch type to Fargate launch type, then it can be easily done, and you can make them run alongside of each other in the same cluster, and probably do canary deployment before finally moving to 100% of your traffic to the new Fargate launch type. Okay, and lastly, both ECS and EC2 launch types share the same AWS services such as VPC or CloudWatch or AWS IAM. Okay. So for the registry, you have the option to host them in ECR, as I mentioned earlier, or if you have any public repositories or third-party private repositories that you use, then that will work as well. Okay. So for the data layer, well, we all know that the front-end application space innovates in a fast pace. And having said that, we have to make sure that our database can keep up with the innovation and the scalability as well of your application. So AWS actually has 15 database options for you, and it has a complete family of purpose-built databases that to give your customers the right tool for the right job. So they can spend less money and be more productive, and then, of course, improve the customer experience. And in terms of servers, there are two database services that is actually serverless. So the first service that we're going to look at is DynamoDB. So you can think of DynamoDB as a serverless database in a similar way that Lambda is as a serverless compute. So DynamoDB provides a persistence layer that you can leverage for your applications without managing servers. So aside from that, it's a fully managed NoSQL database that is designed to provide consistent and low latency or single-digit millisecond latency regardless of scale. So again, there's no hardware provisioning, there's no software patching or upgrades that you need. It will scale up or down automatically, and it also continuously backs up your data and make sure that you can encrypt all your data by default, and it is fully integrated with IAM for security purposes. So another cool thing or cool feature that DynamoDB has is the global replication or the global tables. So by doing this, you can replicate your DynamoDB tables automatically across a choice of your AWS regions. So this gives your application high availability and also durability and multi-region fault tolerance. So the way that it works is when you create your DynamoDB global table, it consists of multiple replica tables that DynamoDB treats as a single unit, and every replica has the same table name and the same primary key schema. And when the application writes data to a replica table in one region, then DynamoDB would propagate that write or that data to the other replica tables in the other AWS regions automatically. Okay. So what about Amazon Aurora? So for those of you who are using relational databases, we have here Amazon Aurora Serverless. So it is an on-demand auto-scaling configuration for your Amazon Aurora, where the database will automatically again start up or shut down or scale the capacity up or down based on your application's needs. And right now it supports MySQL 5.6 and 5.7 and also version 10.7 for Postgre compatibility. So aside from that, when Aurora Serverless, scales your capacity or it scales up or down based on the load that was generated on your client, then the good thing about it is it does not affect your applications at all when it scales. So there's no downtime for that, and it can scale to zero capacity when there's no connections for a 5-minute period. So that means you get to do some cost savings with that because you don't get charged when you don't have any capacity, or it will automatically scale down or shut down when you don't need them. Okay, so that's it for my presentation for this evening. And maybe I'll just quickly show you what I did for as a mini project or on a quick project for myself. So this site right here was actually built on pure serverless. So these are all hosted in S3. So as you can see, this is the front page. You can have a subscribe to or a field here, and then you have your about page, you have your flight status, you have your contact us, and when you click book now, it will actually redirect you. Oops, I think this is not updated yet. I have made some changes kasi earlier. But okay, let's see if that works. Okay, so syempre, when there's a demo, it won't be a demo if nothing goes wrong. So let's see if this because it should redirect you to the Cognito page, but I think it has not yet populated because I just updated it earlier. Anyway, maybe I'll just redirect you. Sayang naman if you don't get to see it. I wanted to show you pa naman the Cognito login page. Let me check if I can do some quick workarounds here. Okay. Yan, and voila. Okay, nag-work siya. Okay, so this is actually what I was telling you about. So this is the Cognito hosted UI. So you can integrate it with your social media account. So for myself, I decided to integrate this with Google. And then I also have here the option to sign in via username or password. Okay. So I've already created my own account, and take note, these are all done via the Amazon Cognito. I did not code anything here, so I simply integrated it with Cognito, and then it gave me this login page. So what I just did is, of course, I customized it. I put a banner here for my Lipad PH, and then I just tweak some lettering or the spacing and whatnot. So when you sign in, it will redirect you to the splash page that you have chosen. But again, it forwarded me to a sign-on page. So again, this is to show you that even when you're using Cognito, you can choose to have your own login page if you want to have a customized background, if you want to have a customized page, you can still do so. So I'm going to input the same credentials and then log in again. Okay, so it will take me to the booking page. So in here, I can start booking. So I can say from origin is Manila, destination would be Bali, departure would be sometime this 4 I think that's already one. Then my return date would be September, travelers would be 2. Okay. So if you search, then you will see here some of the flight numbers that are available. So again, these are all done via serverless. So it's actually pulling the data from a DynamoDB database. Okay. So when you want to book, you can just click book, and it will redirect you to a page that I've created where you can input your name, your email, your phone number, and also a card number. So actually, I'm not going to do that. So I just wanted to show you the power of a serverless application. So you can do this by 1 or 2 week, right? If you want to tweak something, if you have a personal blog that you want to put up. So it's a good way to try S3 and CloudFront and DynamoDB, just to learn something new, right? And when you have your downtimes and whatnot. Okay, so I guess that would officially end my session for this night. So let me pass the mic back to Louis.
Thank you so much po, Miss Dams, for the wonderful and valuable talk po. And now, we are open for the floor for the questions.
Yes,
And we have
actually,
a
I see
question.
one question here. Where can we find resources to learn AWS services for newbies? So actually, we have a dedicated site for that. Let me grab that link so I could share it with you. We also have a lot of workshops that you can do by yourself, especially in terms of containers and serverless and whatnot. So it contains a step-by-step guide that you can follow along, and you can register for your AWS account. So it has a free tier. So for the first few resources that you're going to spin up, free naman siya, pero you have to check. I'll give you the link then for how you could check yung included sa free tier para you can make sure that you're not incurring costs on your first sign up. Let me quickly get that.
Thank you. Thank you po. There is another question po from Miss Erica May Calderon po. Does AWS have currently program which program can leverage and how to join these programs po?
Yes, actually, we have AWS Educate. You can. This is actually for both the educators, like your teachers, or even the students themselves. So you can start your cloud journey in here. I'm not sure though how I can paste the links. I don't see it here. So should I just share my screen ba? There, okay. So actually here's the AWS Educate. So you can register here as a student or as a company or a recruiter. So, or if you're an educator, if you're a teacher, I'm sorry I didn't get if you are a teacher or a student, but if you are an educator, you can also sign up for the AWS Academy and you can get in touch with our Educate team. And there's also one here for students. So if you are a student, you can input your details here and you can subscribe. And for the AWS free tier, you can sign up for this and you can see here the different free services that you can do if you decide to sign up using your personal account or whatnot. So here you see that there's a 12 months free. There's a lot of trials. There's a lot of services that you can access during that free trial. So for EC2, you have 750 hours per month. You can store 5 gig of storage on S3. For RDS, you can use 750 hours of per month of the DB T2 micro database. So feel free to utilize all of these offers, using your free account or whatnot. So for the resources, is AWS hands-on getting started. So I'm sorry, hindi ko kabisado yung mga URLs, but you can Google them up and it should come here. So these are the different hands-on tutorials for your AWS need. And if I can, I will drop these links that I've shown you later on sa page na lang siguro ni StackLeague, or I will just give them to Hi-Fi and the team that could post these references for you. So as you can see here, you can select the different categories for containers, for serverless. Oops. And this will redirect you to different tutorials or hands-on workshops that you can use and follow along. So it's a step-by-step guide on building your own serverless web application. Okay.
Thank you po, ma'am. Here's another question po from Stephen Johnson de la Peña. Good evening po. Can we host CMS like WordPress on AWS po?
Yes, you can totally host. You can host your WordPress blogs to AWS. So you can launch your own EC2 instance, and then install everything that you need there. Or you can use also yung optimized AMIs built for WordPress blogs. So you can run search for those in the AMI page or console, and then that should lead you or spin up a EC2 instance that is built for WordPress.
Thank you po, ma'am. Another question po from J. Marie Erica Jonsho del Sevilla po. As a student and a total beginner at AWS, what is your recommended first step to do for me to learn AWS? What AWS service should we learn first?
Actually, I would suggest you to go through, we have different certification path kasi, pero we have this cloud practitioner. So that includes yung mga, it's like a cloud 101. You get to learn about the business values of it. You also get to touch on the different services that is, commonly used in AWS, and the different services for compute, for database, and whatnot. So I would suggest you to go through that. Even, I mean, hindi mo naman kailangan tapusin yung whole certification, to go through the certification itself. You can just go to the training and certification page of AWS, watch videos, learn from it, and then if you want, you can also take it up to the next level and take that certification. Of course, that will be an edge then for you, diba? Yun. Pero I guess for me, if you're familiar naman with, like, you have a programming language that nakabisado mo, like Node.js or Python or whatnot, once you've done your Cloud 101, you can try getting your hands dirty by trying on EC2, S3, and Serverless. I think that would be really cool if you could do that. So again, if you have the time, you can check the cloud practitioner and the different topics included there then. So practitioner, let me just get it. Oops. Or I'm there. So this actually is a certification path, pero you can still get the different, the foundation here, and then use that to learn the different services. So you can also go to our training page, training and certification page. So this is where you can access yung different learning materials that are actually free. So you can see here, you get Cloud Practitioner Essentials. It's a fundamental course and it's 6 hours. So definitely marami ka na matututunan dyan. And if ever you need to, or if you want to deep dive on a specific domain or category, so you can also search for that in here. So it also has naman yung mga different levels, like fundamental, beginner, advanced. So you can gauge kung ano yung level of yung details na makuha mo from that video.
Thank you po, ma'am. Another question po from Shanley Rosero. If you are integrating from third-party platforms, what AWS application should we use?
It actually depends on ano yung integrate mo with AWS, because the AWS services that we have, there are a lot of the services that we have that can be integrated with third-party platforms. So, for example, on the top of my head, ang naisip ko is, example, if you have a security events, yung mga SIEM, like management system. So if you are collecting yung CloudWatch logs or logs from application, you can collect that on the AWS side and then integrate your third-party applications with us, and then that those logs could be thrown to your own management system. So that's one way of doing integration. Another integration would be, for example, if I use Amazon Cognito and I wanted to do additional authentication layer where you want to have OTPs, sent to your users, so I can integrate that with third-party messaging services. If you don't want to use built any AWS SNS, you can integrate with different third-party messaging services by using a custom authentication flow with Lambda, for example. So it actually depends naman on your use case and kung ano yung gusto mong integrate with AWS. services.
Thank you po. Another question po from Caceres John. For IT engineers trying to upskill for cloud or AWS, what kind of AWS service or application would you recommend, especially the one being utilized in enterprise level? What are the step-by-step learning curve?
Um, Actually, I would suggest din kasi to familiarize yourself with the fundamentals or the basics kasi that's important. You have to understand. Again, these are all what I'm saying here is lahat to are included when you do your cloud practitioner, when you do your solutions architect associate. So all of this will be covered in naman. So if you want, you can follow the curriculum that we have in those certification. Diba? And much better if you take the certification exam, but it's okay if you don't because medyo may kamahalan nga siya. So maybe if napag-ipunan mo na, then you can take that. But for again, much better if you would know the basics of cloud computing, you know the VPC, how the VPCs work, how the EC2 instances work, how you could spin up an EC2 instance, how you can run an application. And most of the time kasi, there are ways for you to learn using mga webinars, by reading them online. Pero it's a whole different thing when you are doing hands-on. If you are getting your hands dirty. So I suggest that while you are reading up on something or watching online for specific webinars or learning on YouTube videos, you also supplement that with your hands-on activities. Okay. In terms of the services and application, it's actually because we have a very broad number of services that we offer here in AWS. So that would actually depend on the company that you're in, kung ano ba yung kailangan nila. So if you think there's a space for a company to innovate, to use serverless, there's an opportunity for where you can use serverless, diba? You can start learning that. But on an enterprise level, depende rin kasi on where they are currently in their infrastructure. If they're using virtual machines, if they're using EC2, then of course you start with that. And then afterwards, if you see na meron kayong data store, ganyan. So I guess my point here is to start kung ano yung mas relevant sa'yo, where you can apply them kung nasan ka ngayon. Kung IT engineer ka for a company, look for something na magagamit mo ngayon. And if not, maybe create your own personal project. Like what I did. I created my own mini website na just to play around with the services that could familiarize myself with how each services work. So yun.
Thank you po, ma'am. Another question po from Wab Roquesa. What are the consistency model for modern DBMS offered by AWS?
I'm not
DBS.
sure what you mean by consistency model. Maybe we could elaborate that, or I'm not very well versed with that. So maybe I could answer that offline for you.
Thank you po. Another question po, ma'am, from Jasper Sibayan. What Amazon service or skill are in demand right now so you can earn more?
In demand, actually, in the field, what we are seeing most of the time when talking to our customers is that a lot of them wanted to move to modern applications. Modern applications meaning this consists of yung containers, again, yung modern architecture where you use containers, where you use serverless, where your application is made up of different small pieces that are loosely joined together. So yun yung madalas namin nakita, and also with AI/ML because AI/ML has a lot of feature, marami kang pwedeng gawin, especially now that we have all this data that we could utilize. So those are things that I see that are in demand right now. So if you could if you could practice or experiment something with those with along those lines, so you could try that.
Thank you po. Another question po from Tickboy Palaboy is serverless economically small to medium business scale?
Yes, because
Small.
as with any other services naman in AWS, so it's pay as you go. So you only pay for the resources that you use. So if your let's say if your website or your application consumes little resources lang naman, so of course that will cost less versus on hosting them in let's say a big EC2 instance. So some appreciates yung serverless because you only get charged for yung exact utilization nyo. So for example, if your Lambda or if your API gateway is triggered, then yun lang yung babayaran nyo. Right? And yun, if you have a static website, you can use S3 instead. So ang babayaran mo lang of course with S3 is the amount of storage that you incur in S3, and of course yung data transfer in or out that you would consume. But basically yun kasi yung pricing model niya is a bit different from the EC2 instances. Like with EC2 kasi there's a fixed per hour price that you get to pay, but with serverless you only get charged by the different o kung how many invocations are there or kung nagamit ba yung resources, where they access, so ganyan. So again, you only pay for the resources that you use or you consume.
Thank you po, ma'am. I think po there's no other question po. Question po wala na po. Before we officially close the program po, I would like to invite everyone in our StackLeague Accenture career session on August 31st. The topics include successfully finding a career in the digital landscape and toolkits for winning career in the new normal. Registration is now open. And again, thank you for joining us at this StackLeague AWS Tech Session, Serverless and Containers. If you know someone who should be part of the league, invite them to register now at stackleague.com. See you at the next StackLeague event. Thank you. Successfully